I'd now like to go into some of the more nuanced details of the calculation resistance, some of which I touched on earlier and some which are a bit new. So first of all, you'll see here that there is a K, X, and Y connection type. So when we go to see detailed results, you can see that the moment needed for equilibrium due to this eccentricity is put on the left side of the cord. And for the X connection, all the cord reactions are on the left side, likewise with the Y connection. So that is because when we previously set this up, we put the left side as pinned, or pretty much we defined all our forces on the left side. So the program is pretty much assuming that because the only forces it knows are on the left side of the cord, it's going to assume that this right side here is free and has no reaction, and therefore it's not going to assign any forces. If you added additional forces, now maybe you had 1,000 kilonewtons on the right side, you can see that if you view detailed results, all of a sudden you have your free body diagram here with the axial force just on the left side, but now the moment is split up on both sides. And similar once again to the X connection and the Y connection. So the reason this axial force is on the left side is because we've defined the left side as pinned, and we've put the axial force on the left side, which is required for equilibrium. But however, the program now knows that both sides of the cord can be effective for resisting load, so it no longer assumes the right side is pinned, so it will split the moment and the shear up 50-50 on either side, because this is a continuous cord, so that assumption can be effective. You might be wondering, though, what happens to this additional 1,000 kilonewtons of load. So as you can see from these free body diagrams, or just from if we remove this 1,000 kilonewtons of load, that for equilibrium, you only need this load acting on the left side of the cord. Everything else you add is just extra load which is acting equal and opposite on the cord, or essentially this 1,000 kilonewtons in tension is being counteracted by an extra 1,000 kilonewtons on tension, tension on the opposite side of the cord. Likewise, if we added some moment here, if we added 20 kip-feet of moment on either side, you can see that these are canceling each other out. However, if you go to the free body diagram, you can see that to be put in equilibrium, you don't need to consider those extra forces. To be put in equilibrium, the program's only going to consider the forces which are being added on top of these extra, the program's only going to consider the forces in the branches and isn't going to consider those loads which are added on top of any forces which are needed for the immediate equilibrium of this free body diagram. Rather, what the program does is it considers those extra loads as preloads. And now when doing the analysis, the program is going to assign these preloads to a different connection type each time. So you can see you have this extra table here where it defines which connection has the preloads assigned to. But this isn't very intuitive, so it's a bit easier to understand what's going on in the calculation sheet. So here we have our calculation sheet, which I showed in the last tutorial. And now if we scroll all the way down to the capacity checks, you can see we now have combination 1. Apply an 1,000 kip cord force and 20 kip-foot cord moment to constituent free body diagram number 1. So pretty much the analysis is being repeated each time for each connection object. The first time it's repeated, it takes this free body diagram number 1, and it applies all the preloads onto it. And then it does the analysis using this updated free body diagram with the preloads, and then it considers the free body diagrams of the other connection types without the preloads applied. So if you were to add all the free body diagrams up, you would get all the loads which comprise this overall connection here. Likewise, if we go to combination 2, now all the preloads are applied to the X connection, free body diagram number 2, and you can see that image here. And now the K connection checks are done using figure 2, which is the free body diagram without preloads. The X connection gets all the preloads from figure 6, and the Y connection gets no preloads. And then the final combination is it applies all the preloads to the last connection free body diagram, and then runs the analysis. And you can see for each connection analysis, there's a total utilization ratio associated with that. So that's where these tables start to make a bit more sense. You can see that there's a different utilization ratio associated for each limit state and each connection type, depending on which connection is preloaded. So for the branch at 135 degrees, depending on if the preload is applied here or if it is not applied here, the utilization ratio is higher when the preloads are applied. Then you get your governing cases where it tells you the governing case for when preloads are applied and when they aren't applied. And then your total utilization ratio is the worst case scenario for any of the connection analysis scenarios. So it will add up the effects of the K branches in the K, X, and Y connection for preloaded connection number 1. Then it'll do the same for the combination number 2, and then the same for combination number 3, and it will return the worst utilization ratio for each member. So that's how additional loads being added onto the connection, which aren't immediately associated with a certain connection type, are handled in this program.